Hello and welcome to this video, which is part 2 of the set operations in coding hands-on part 2. Here we will instead, like in the first video, we generated some data or we inserted some data and did some set operations, and that was like very simple data to work with. However, now we will use the Sakila database, and this is more, not very big database. It has several tables. And we will show how to use different set operations in the Sakila database. Since this video is the first time we'll work with the Sakila database, I will show you how you will ingest the data into DuckDB to work with. Because this is originally my SQL database that I have created. In Kaggle, which we will go to soon, you can download the database file, which has been ported to SQLite. And for us, we need to be able to read that database. Here I am in the browser, and you can search for SQLite Sakila sample database, and you will come into here in Kaggle. And then just download this database, and you will get an archive.zip. Unzip it and copy that folder into Visual Studio Code. I'll meet you in Visual Studio Code and I will show you this. Here I am in Visual Studio Code, and you can see I have copied in the folder into a data folder. However, here we have a lot of SQL files to actually generate this data in SQLite, but I won't need that. readme.txt is good to have if you want to read more about the Sakila database. Basically, it's a fictitious database designed to represent a DVD rental store. That is what you need to know. And then we have the PNG here, right? This is the actual schemas. This is the relationship model, the data model. You can see as an entity relationship diagram. You can see the entities and what type, these are the tables and what type of columns they have and how they're connected to each other. I won't go into detail how this works because this is more the scope of a data modeling course. Right now we are working with DuckDB. What I want to do now is to read this light database into DuckDB. To do this, we do like this. I start a new folder, I call it SQL. And inside this folder, I will create a file called load. To load in DB, what you need to do is install SQLite. This is an extension. We need to install it, and then we need to load SQLite extension. And after you've done that, you do call this SQLite underscore attach. And here we need to find the actual database. This is the database. And I will run this from my root folder. It means that I will see it from the data. I see data, and going in there, I will go into SQLite and dash Sakila.db. And that is it. I will save this one. And what we will do now, I'll close this. I don't like this. Remove that one. Let's do DuckDB, Sakila.duckdb, and I will do input redirection, go into SQL, load Sakila.sql. I run this one, and it says success, Boolean, 0 rows. Let's take a look if it's successful or not. db, Sakila.duckdb. Yes, test. Now you can say, wow, cool, I've gotten all the tables that I want, right? These are all tables. And let's do, for example, from film. And you can see, 1,000 rows. Great, it works as we expect it to do. Now I will close this down and I will open this up in the UI. DuckDB-UI Sakila.duckdb. Since this is the first time we're working with Sakila database, we will do some EDA first, Exploratory Data Analysis. However, let's create a few scripts in our SQL. I open a new terminal here and I will cd into SQL, and here I will do patch. Let's see, what do I want? EDA Sakila.sql. I want to have set operation underscore Sakila.SQL. These are what I want, and then I will go back to my DuckDB, and I will go into EDA, and I will clear this out, make it smaller like this, and make the windows nicer to work with. Something like that. Let's start with desk here to see what we have. We have several tables here, right? Then just do like from actor, for example, and then we'll do from film, from address, to just try to understand them, from category, from city, from country, from customer. A few of them, maybe take film actor as well, just to understand it. From actor, let's see what we have here. Here you can see we have first name, last update, and actor ID. And then from film, and you can see there's a film ID, title, description. Actually, I will take film actor after film because you will notice something here. Copy this one. Film actor is something called an association table or a bridge table. Basically, it has actor ID here and it has film ID, right? It has actor ID and film ID. What you do is that you join together actor ID and film ID. You will get both actor and film into the same table if you do the join. This is a type of bridge table. You can see we have actor ID, which corresponds to this actor ID here, and we have film ID, which corresponds to this film ID here. Then you can get the title together with which actor have participated in which titles, right? We have that, and let's continue with address. And you can see, yes, address here, we have address ID, we have the address, and then we have address to, district, city ID, etc. And there's a lot of nodes. Just to skim through a little bit from category, and you can see a category, we have a category ID, and then we have the different names. From city, can this be grouped together with the address ID maybe? We have city ID. The question is, does the address have city ID as well? Address ID, we have city ID. Great. I will put them together. City and address, and probably address will have a country as well. If we take a look here, no, it doesn't have. We have city ID. Let's see if ID, yeah, city ID has country ID. As you can see, you can do three-way join. I will not talk about joins much in this video. It's in the joins lecture. I will talk there. But basically you have address, city, and country, and you can join them together and you will get the full address, right? I won't go through all of them. Let's continue with something else. We can do select. Take a look into count star number movies. If we do from film, right? Then we can do count distinct title at unique number of titles. Copy this. Let's see, count line 4, count, yeah, there should be a comma here. Should be a comma here from this one. And you can see, yes, they are unique titles. We have 1,000 movies. We'll take a look into select. I'll just copy a few here. Select distinct rating from main.film. Let's do that. Yeah, and then we have a few ratings here. This we have done. We can do, yeah, there's some more exploration. We can do, let's type it out. Select star from, yeah, film actor I've already done. Let's do describe table film actor. Just do some random EVAs here. Film actor, then you have actor ID, film ID, and last update. This one we have already taken a look at. Have we taken a look at customer? Maybe not. Let's do that. From customer, and you can see, there's first name, last name, email, And the store ID, customer ID, which store you have bought from and which address you have, etc. This one we have here. Let's take a look into, can we do, for example, let's use some aliasing. I'll show one thing. Select from customer, and I will alias it as C. And then we will use, let's see, customer type C dot first name. I'll show you what this means soon. C dot last name, where C dot first name, like, let's start with D, something like this. We'll just copy this one and I will explain what it does. Run it here. We can see customer as type, then I'll just call it type here, right? This is just to create another column, and then C dot first name. C is we reference it from the alias. This is starting to, we haven't done this before, I think, but the thing is now when we're doing compound queries, that is where we're combining several queries together, then you should alias them, that you know what column come from what query, right? From what result set. This is one query here. Select these things and you have this customer as C, and then you reference all the columns through C, right? C dot, using the dot notation. And here I use where C dot first name, like D and percentage. This will match all that will start with, all the first name that will start with D, right? You can see first name, Dorothy, Donna, Deborah, etc. These were like a few EDAs, and there's many more EDAs that can be done. More EDAs left for the watcher or reader. If you're watching this video, then definitely you should pause and do more EDA, that you understand the Sakila database better. Let's move on to set operations now. It's time for doing the operations that we have learned in theory. Let's start here. Select, actually I will use this here. I will copy this one. Here we pick out customer as C.first name, C.last name from customer C, where C.first name, like, I will start with A here. And this will only give everything from A, right? If I copy this one, you can see it starts with all the first name that starts with A for the customer. However, now I will union means that we get the first result set. This is result set A, and then union result set B. Take a look into this picture here, where you have union, where you see the Venn diagram, that we have everything in A and everything in B, but it will remove all the duplicates, right? For results B, I will select actor, A dot first name, comma, A dot last name from actor A, where A dot first name, like A, start with A. I'll copy this one, and now you can see, now we get actor, customer, right? We have everything that starts with an A will be added here. If I run it again, you can see it's changing the order, right? You can order it. Order by first name, for example. Now it's a deterministic order. What you can see here is that we have the first result set, which is this one. We get all the customer, and then we union them with the actor, all the A's in the actor. This is the union operator. This will, if I give a comment here, it's select all customers and all actors. Let's see. Select all customers and all actors starting first name with A. Let's continue, and I will try to find the overlapping names between actors and customers. To do that, we do even bit more space here. Find overlapping names between actors and customers. Select from actor A. Actor A means actor as A. And what do I want? I want A dot first name, comma, A dot last name, right? And then I want to do intersect. Intersect means what is in common in result set A and result set B. Take a look into this Venn diagram here. Select from customer C. Then we do C dot first name, comma, C dot last name, right? Copy this one, and let's see if we find someone. There is an issue here. Table with name customers does not exist. It's called customer. Yes, Jennifer Davis. You are the only one that is in common in both. So just to check that this is correct, we can do like this. We can select from actor A where A dot first name equals Jennifer, or like something like this. Like Jen, and you can see there's a Jennifer Davis, and I will do similar thing with the customer here. Instead of A, I will do C. And you can see, they have Jennifer Davis in the customer as well. And also in the film, we have Jennifer Davis. Great. Then let us find all with initial JD and record its type, actor, customer. That is the idea now. Let's do select. Let me in more space here. Select from actor A. Let's see. And I will pick actor here and as type, comma, A dot first name, comma, A dot last name. From actor A, where A dot first name, like J, and A dot last name, you can see that D percentage. And then we want to keep the duplicates. We'll do union all. Actually, there won't be any duplicates because we have a different, they will all be unique from A and B. We have actor for A and customer for results at B. From customer C, and here I will do customer type. And we'll do C dot first name, C dot last name. Actually, since type is a reserved word, it's better to do like this. However, this will be small letters actually, but it's where C dot first name, like, actually I could copy this, right? Just because this is saying, and C dot last name, like, D percentage. This is our final query. Let's run this one, and you can see, yes, everything that starts with J and starts with D for last name. And you can see here we have Jennifer Davis twice, because we have one for actor and one for customer. And then we had some other that are actors that have JD initials. I hope that you have learned how to work with compound queries where you use 2 or more result sets together using union and intersect. Actually, you can compound more if you want. You can do another union here or an intersect as well. Set theory is really powerful when working with SQL. You use set operations to act on rows, as you have seen now. But we will use join later on, where we will go into how to combine the columns together. That will be quite interesting. Let's do Control D now to close this down. And if I check here, I don't have .val file. I'm fine here. But make sure you commit and push to GitHub. Yes, in this video we have gone through set operations using the Sakila database. As you've seen, the Sakila database is actually quite large and extensive. We will actually work with it in several lectures. Don't worry if you haven't explored all of it, because there's a lot of fun to do with the Sakila database. We have worked with an EDA, but first and foremost we have been able to connect it to DuckDB using the SQLite extension. That is quite cool that the DuckDB can read SQLite. And DuckDB is cool. You can read many different data formats and work it in DuckDB, and you have the power of DuckDB SQL. Really nice, and I hope that you learned a lot, and see you in the next video where we'll go into joins.